All right, everyone, in this video, we're going to be going through trig ratios, as you would know, maybe SOHCAHTOA from last year. A lot of this stuff that we're going to go through today, you have already seen in Year 9. In fact, you've seen all of it in Year 9 before. We're going to go through trig ratios and also doing trig ratios the other way and actually finding the angle. So if you can solve a side length, we've got two different ones. We've got ones where we've got the unknown as the denominator, and we also have a side length. I can use trig as well. So there's different. We're going to be looking at a couple. We're going to be looking at, first of all, let's have a look at trig ratios. So first of all, you can see here that we've got these ratios, and notice that this triangle here, 3, 4, 5, look, 3 matches up with 6. Can you see that they're similar if I was to double that? If I was to double that side length. Likewise, if I was to double 4 to 8 and 6 to 10, those true triangles are similar. So even though they have different dimensions, they're going to have the same, what we call trig ratios. And that is, well, let's have a look at these. First of all, you might remember saw, car, toa. They're the 3 trig ratios we're talking about. Sine, cosine. Now, by the way, it's not sin for I committed a sin. It's actually short for, sine is short for S-I-N-E. And tangent, tan is short for tangent. Now, why do we remember SOHCAHTOA? Well, first of all, let's have a look. The S, okay, and is actually what we call the opposite over the hypotenuse, okay? If I have the adjacent and the hypotenuse, then we use cosine. If we use tangent, we're looking at the opposite and the adjacent. So, for example, if I was just given, and we'll get into this in a second, here's my reference angle theta. Now, in maths, we use alphabet, Greek alphabet, alpha, beta, gamma, delta, pi, phi, omicron, all of these things, all from the Greek alphabet. Theta is just from the Greek alphabet. So often you will see theta as your reference angle when we're doing these problems. And so that means that sine of theta, we'll get into, let's have a look. Look over here, theta. What's opposite the angle? What side length's opposite the angle? The 3's opposite that angle, isn't it? And what is the hypotenuse? We know that the hypotenuse is the long side length, which is this. So sine theta is opposite over hypotenuse, and that's why that would be sine theta for this triangle would be 3 over 5. Okay. Likewise, cos theta, if I was to do it in another color, let's go to pink. Sine theta, if I was to do over this one over here, likewise, sine theta is 6 over 10, opposite over hypotenuse. But again, 6 over 10 as a fraction can be simplified to 3/5. So notice, different triangles, they're different, but they are similar triangles. You can see that we've just multiplied each of those dimensions by 2, and we're still going to get the same trig ratio. Now, if I look at cosine, let's have a look at cosine here. Cosine, doesn't matter which one we look at, but look, see here, we're looking at the angle theta. Cosine uses the adjacent, so it's 8 is adjacent to theta, and 10 is the hypotenuse. So 8 over 10 is 4/5, so cos theta being 4/5. All right, now what we're going to do is we're going to break this up and go through more, and tangent likewise, by the way, is opposite over adjacent. But before we do that, let's go all the way back to doing these step by step. Now, step 1, using trig, we've got to make sure that we label the triangle correctly. Now, depending on where the angle is, if I've got angle theta, the opposite is always the side opposite that which is in the hypotenuse. Okay, so opposite, if I note that I could be be very careful, because what happens if, now I'm going to use another Greek alphabet, phi What's opposite to that one? Would that now be the opposite if I'm talking about this angle here? No, it wouldn't. The opposite would actually be down here. So it's not locked in that that side's the adjacent. It's adjacent to the angle that we're looking at. Okay, so if I was to rub that out, if we're just solely looking at theta, the opposite is always going to be on the other side. Hypotenuse is the nice easy one because that's always the longest side, which happens to be on the other side of that right angle. And notice as well, we can't do this without right angles. We need right angled triangles in order to use SOHCAHTOA. Okay, and adjacent being adjacent to the angle. Okay, so step one, what we're going to do is we're going to label each of these triangles, and we're going to have to label it with O, A, and H. That, before you do anything, you cannot use SOHCAHTOA if you can't label a triangle. So let's do that. We're looking at 53 degrees. So is this 2 opposite of 53 degrees, or is it the hypotenuse? It's adjacent, isn't it? Okay, so that's the A. And over here, X is the unknown side length. Yes, it's unknown, but we're trying to find it. So what we're going to do is we want to label that. And of course, in this example, we wouldn't need the opposite, but we might as well write it anyway. Over here, 29 degrees, this side is adjacent, the long side is the hypotenuse. That obviously leaves this side being the opposite, doesn't it? And likewise over here, 75 degrees, it's been flipped over around this triangle. We know that this is always going to be the longer side is the hypotenuse. This side here being adjacent to the angle, X, and this side over here being the opposite. Okay, so we've got to label them correctly. If you can't do that, we're in a lot of trouble. Example 2, you now need to identify and look at your triangle and see what side lengths we're using. Now over here, I just labeled, this is exactly the same triangle, AH, OH, and over here we had A and O. Okay, so if you have a look and we get our highlighter out, then you notice that we've got A and H, O and H. We're always going to be given 2 things and we've got to find the other, whether it be finding angles or side lengths, and O and A. So what we've got to do is look, O and A, we've got to use tan. A and H, we've got to use cos. And O and H, we're going to use sine. So step 2 is actually working out which trig ratio to use based on what your 3 knowns are. Okay, so we know the angle. In these examples, we know all of the angles. So we know an angle. We know one side length. We're trying to find the other side length. All right, so what we can do now is let's write out what our trig ratios are. We've established that we've got the saw is sine. The car means cos. So let's go over here. This is using A and H. So we've got cos. I'll write it out. Cos theta is equal to A on H. That's the first thing we should know. You don't necessarily have to write that because we know that A is 2 and H is X, isn't it? Okay. Now, of course, we know what theta is. Theta is 53 degrees. So let's write that in there. Okay. And the reason why I'm also going to do this is you might notice that what are we trying to find? We're not trying to find cos of 53. The calculator can find that. We're trying to find X. So what can I do with X? What can I do with X? I might just pause this video whilst we're in class because I'd like people to know what can we do to X. So we've just sort of discussed, and hopefully you can see it, we've just done the algebra and linear relations unit, and we've done a lot of algebraic fractions. We can actually swap those. We want X by itself, so I'm going to get X over here. And that's going to be 2 divided by cos of 53 degrees. And of course, if we want to do that in a calculator, well, we'll need to do that in a calculator. Let's go to our CAS. We'll open up our CAS calculator, and we'll need to do this on your CAS. So in these tests, you're always going to have a CAS calculator because I don't know what cos of 53 degrees is, and nor do you, and nor will we ever. because it's going to be to so many decimal places. There's some examples of 30 and 45 degrees and some of these other angles, which are nice sort of, you know, nicer numbers, but no, you're going to need to use your calculator. So you've got to bring your calculator every class. 2 divided by cos 53. Hopefully you're getting the idea to save yourself time. Do that. Now you don't have to type in x equals because x equals, we just want to find the answer. 2 divided by, now hopefully you're in degree mode as we discussed last time. Degree mode. If it's in degree mode, all good. And let's go trig and we go to cos and let's put in 53. We're in degree mode. Now it's going to give some all sorts of funny things. That's actually an exact value. It's not very useful to us, so we want to hit Control Enter. So it's 3.32. We're rounding off, so I'll say approximately 3.32. Okay. Now over here, we've now got, again, likewise. Now, that's step 2. Obviously, step 3, I've broken it down. I've done it all just in one there. Step 3 was writing the equation. We did that, didn't we? So step 1 was labeling the triangle. You need to label the triangle properly. Step 2 is work out what trig ratio you want. Step 3 is insert those, and then step 4, rearrange to find our unknown. In this case, it's x. So I've really been through all of that with you. Let's do that together again now. Step 1, we've got O and H. So that's the saw in SOHCAHTOA, which means that we've got sine of theta. Let's just write out what we know. That's the opposite over the hypotenuse. You know what? I'm likely to give you half a mark, even if you wrote that and didn't finish it off. You know, if something's worth 2 marks, I can at least see that you're using the right trig ratio. Now, that's going to be equal to, let's write it out in more less general terms now. Sine of 29 degrees is equal to opposite x over the hypotenuse, which is 7. Now, notice before we had the unknown as the denominator. See, the unknown was on the bottom. Over here, we've got the unknown on the top, which means that do we need to move this x? Does this x need to move anywhere? No, but what does need to move? Because we don't want x divided by 7. What are we going to do to both sides? We're timesing by 7, but likewise, if you saw like this as 2 fractions, then the 7 can go and nick off up there, can't it? Yeah? So x is 7 times sine of 29. That's the exact value. Let's go ahead and find it in the calculator. 7 sine of 29. Let's go over here. This time, now what I see a lot of students do is they do this. They do things like they'll use the solve function, which you could, but it's a waste of time. If you did this, and you could do it, you could go menu 3-1. And remember what we had is on the left-hand side, we had sine of 29 degrees. And then we said that that was equal to, wasn't it, x over 7? Yeah? X over 7. Now, if you told press enter, the calculator is going to spit it, isn't it? Because it doesn't know what it's solving for. But what about if I was to do this, and let's go, comma x. Wow. It's exactly the same thing, but in my opinion, that is much slower to do that, what we just did then, than simply just rearranging, getting the 7 up. Or if, as opposed to this, so you've got solve as opposed to 7 times trig sine of 29. If you ask me, I know which one I'd rather be doing. Do that one. Okay, 3.39 is what our answer is there. So that's going to be 3.39. Now over here we've got OR, that is the tan theta, is opposite over adjacent, which of course is tan of 75 degrees is equal to opposite, which is 10.3 over x. Again, we're back to x being on the bottom. So what do we need to do? We need to, where can x go? We could do this as a fraction if you like. Again, we could cross simplify. The x could go up there, and we could go straight over here, couldn't we? 10.3. The x and the tan of 75 degrees swap places, and that's what we're left with. We can go ahead and find that now. And so again, you don't need to do the solve function in CAS. You literally just need to write this out, 10.3 over tan of 75, rearrange, write it in your calculator, boom, give us an answer to 1 or 2 decimal places. Okay, so let's have a look. Let's go through that. 10, oops, we'll get better. Control, divide, 10 divided by tan, trig, tan of 75 degrees. You're going to get this ugly looking answer, which is actually, it's an exact answer. It is that, but that's a little bit confusing for now. It's, yes, it is. Okay, let's try that again. So I've copied that down, 2.76 to 2 decimal places. Okay, 2.76. So really, that's as much as you need to know for. We've obviously got to practice a little bit more for 4A trig ratios. What I'm going to get you to do, well, we actually did all of those steps in 4. So I broke it down in 4 steps. I literally went through that just before. Can I get, if you're watching this all in my class right now, you guys can have a go at this. But if you're watching this on YouTube, have a go at these right now. I'm going to pause this and I'm going to go through my answer in a few minutes. If it's on YouTube, it'll be more like a few seconds. All right, give it a go now. All right, so if you've been watching on YouTube, there's my answers there. Feel free to pause it. Hopefully you got the same. Step 1, let's label the triangle. If you can't do that, good luck. Okay, step 2, write out what our trig function is. Saw, car, toa. Saw, car, toa. So if I've got the opposite in the hypotenuse, I'm using sine. If I've got the adjacent in the hypotenuse, I'm using cos, and likewise opposite and the adjacent for tan. And in both of these occasions, we had the pronumeral x, the unknown, we had that as the denominator, which means that we needed to use some cross multiplication and rearrange those. All right. Okay, likewise, I would like you now to have a go at these ones here. I'm going to pause this video in a second. I'd like you to try it, and I'm going to go through this in a few seconds. So give this a go, and I'll reveal my answers shortly. All right, so you can see there that here's my answers for these. Make sure we're stating units. And again, step 1, label the triangle. Step 2, find the trig ratio. Step 3, rearrange. And of course, solve for our unknown. All right. Now, just quickly, let's look at finding unknown angles. And this isn't going to take as long because, of course, it's really just doing what we did in reverse. Can I just say this? What's the opposite to a square? How would I cancel out a square? I'd do the square root, wouldn't I? The square root and the square are effectively like the inverse of each other. Well, the same thing and then we could go through many other things. Okay, if we have a look over here at sine of theta. Now, first of all, I'm going to rub this out. I'm going to go through what exactly we're doing. Notice here we've got sine theta equals, let's just say, arbitrary thing like k. If I want to find theta, what we actually do, the algebra, the mathematics, is we're actually doing the inverse sine of the left-hand side. If I was to do the inverse sine of theta, and then, of course, if what I do to the left, I need to balance out and do to the right, inverse sine of the right-hand side, which we're just calling k. Now, what do you think happens? Like the square root sign cancels out the x squared, and it's sort of like that. What do you think these inverse sine and the sine do to each other? They cancel each other out. Now, do you need to necessarily write like this? No, you don't. Where is it? Okay, here we go. You don't have to write like this all the time, but I want you to understand why they cancel out. Theta is equal to inverse sine k. So we're using the inverse trig ratio, and that's what we're actually doing over here. Please also note that when we do that, we're only going to get values between -1 and 1. We'll go through a little bit later as to why that is. Let's go straight into some examples. Okay. Now, first of all, what I'm going to do is this. What I'd like you to do is, first of all, set up these trig ratios. I've already labeled these triangles, O, A, and H. I want you to write the same thing out you were before. Sine of theta is opposite O, which we know is 1, over H. So you guys in this class, what I'd like you to do is, just using what you can see, if you're watching the YouTube, have a go at these. You also know for triangle B, we've got the adjacent is A, 1.5, and the hypotenuse is 2.5. How could we set up this trig equation? Write it out just like we were doing before, but this time we've got to use the inverse. Okay, so I'm going to pause this, have a go at it now. Okay, we're back. So just before, again, it's the same thing as the same steps. We've got to label the triangles. So over here we've got the opposite and the hypotenuse. So what we've got to do is do the exact same process. If you could do 4a, you certainly can do 4b. We're going to do sine of theta, which we don't know, we're trying to find. That is opposite over hypotenuse, which is, of course, a half. Now, what did we say before? We know that we can use the inverse sign to cancel out the sign. So what we're doing is, I'm going to show you, do you have to show us like this? No, but I'm going to show you again. We're doing the inverse sign of the left-hand side. We're doing the inverse sign of the right-hand side. That's how we get that theta is equal to inverse sine of a half. Do that on your CAS calculator. We discussed in class why inverse sine of a half. Yes, your calculator can tell you, but I've got an equilateral triangle. I cut in half. That becomes now 1. These 60 degrees, which are all 60 degrees, 60 degrees is being cut in half, 60 degrees. I can tell you from an exact triangle that when you use Pythagoras to find that this is root 3, that sine of 30, think about it, if sine of 30 degrees is opposite over hypotenuse, is a half, then what does that mean? What does inverse sine of a half mean? What does that mean? It means that it's 30 degrees, that unknown side length. And likewise, we're going to go over here and we're going to stop because we're going to do this last one. But again, this last one, we have the hypotenuse and the adjacent. So it's cos of theta is equal to 1.5 over 2.5. I'm okay with you as long as you understand why you can skip this step. If you want to go straight from here in your test to theta is equal to inverse cos of 1.5 over 2.5, I am absolutely fine with that. As long as you understand why we can do that. So, of course, how do we do it? We've got to make sure that in the CAS calculator, we're going to go to this. We're going to go to trig, and instead of cos, we're looking at inverse cos. Let's use our fraction tool. Do 1.5 over 2.5. Is our calculator in degree mode? Yes. So our answer is 53.13 degrees. So I think that these two, rather than being treated in isolation, really are working together. What you've got to do now is make sure that we practice this a decent amount, but hopefully what we've been through today gets you on the right track.